Our last video for this learning plan is dividing polynomials. So while this is a possibility for a GED assessment target, it is not as common as multiplying polynomials, but I have seen it. So perhaps one question on the test could be surrounding dividing polynomials. So good news is multiply and divide relate similarly to add and subtract, right? So like we talked about in the last video, when we multiply like bases, we add our exponents, right? So when we're dividing like bases, we can subtract those exponents. So just a little review on the side here. If I have x to the 5th over x squared, that is exactly the same as x to the 5 minus 2, which I know you could do in your head, but that's the same as x to the 3rd. Okay, so when we divide like bases, we can subtract the exponents of those like bases. So if we look here, we have 27x squared divided by 9x. So one thing that is helpful is you can rewrite this in fraction form. So I'm going to do that. I'm going to rewrite this with a fraction bar. So I have 27x squared over 9x. That really helps us see our factorable factors, right? So on the GED test, they make sure when you're dividing polynomials, they'll always be factorable, meaning like the 27 is divisible by 9, right? Or 9 is a factor of 27. You will never have, we'll go through an example down the line here, but you would never have like 28 over 9 on the GED test. They'll always be factorable if you're asked to divide polynomials, meaning you would get a whole number out of it, right? So here, if I just like multiplication, I can separate these out and do my 27 divided by 9, and then I could deal with this later, right? So 27 divided by 9 gives me 3, and x squared divided by x, remember there is an invisible 1 right here, right? So I have x squared divided by x to the 1st is the same as x to the 2 minus 1, which is the same thing as 3x to the 1st, which is the same thing as 3x. Okay? So it's really up to you how in-depth you want to get with your work. A lot of students don't write this step down right here, that 2 minus 1. They just do the 2 minus 1 in your head, and that's fine. If you're kind of rocking through these and getting them right, don't worry about writing it down. But if you're getting one wrong for every 5, say, when you're practicing on IXL, I strongly encourage you to write down all the steps. Because these are fairly easy points, right? As long as you remember. Of course, I understand that's the challenge. But y'all can subtract 2 minus 1. That's not a problem. It's just remembering the rule of subtracting like bases being divided, you can subtract the exponents. Our next one here, I'm going to do the same thing. I'm going to rewrite this in fraction form. So I have 14m squared n squared times 7mn. I'm going to show you just another way that we can write this out in expanded form. So instead of writing m squared, that's really m times m, and n squared is really n times n, right? So it looks like more work, but it might be helpful when we keep going here down the sheet. So again, you can just kind of separate them. I can separate them like this by like factors. So 14 divided by 7 gives me 2. I have 2 m's on top and 1 on bottom, so you could start canceling 1 for 1. Anything divided by itself is 1, right? So I have an m left. And same with my n case. I have n for n, so then I just have an n here. So I have 2mn. If you don't like that way, feel free to do what we did above by subtracting those exponents. Essentially, it's the same thing. So I just want to show you an alternative way. Next, we have 15a to the 4th b cubed over 12a squared b. So 15 and 12 definitely share a factor of 3, but 12 doesn't go into 15 evenly. So really what we can do here is reduce. We could say, okay, 3 goes into 15 5 times, and 3 goes into 12 4 times. So really here I have 5/4. 5/4. 15 over 12 reduces to 5/4. Next, I have a to the 4th over a squared, so I can subtract my exponents because I have a like base of a. So a to the 4 minus 2 is a squared. Now it can be a challenge here. Where does a squared live? Does it live by the 5 up here, by the 4, or on the side, right? So what I would recommend is notice if you just look here, it's heavier on top. Remember how we just did the one above by putting it in expanded form? This a to the 4th is really 4 a's, right? And this a squared is really 2 a's. So I can cancel 2 for 2, and the 2 I have are in the numerator. So that determines where that a squared lives. It lives in the numerator. Okay. For our next factor of b cubed over b, remember there's a 1 here, right? So b cubed divided by b to the 1st is b squared. And again, I have more b's in the numerator. So that's how I know it lives up here. Oops. Just going to extend my fraction bar here. So even prettier would be 5a squared, b squared, all over 4, kind of centered like that. One thing I do want to mention here is if we look at this first one, how we wrote this, and the 5 over 4 is kind of right above each other. I want you to know that these are equal expressions. They are equal monomials in this case. But I also want you to know that this and this is the exact same thing as if you had 5/4 with the a squared, b squared kind of next to it. Oops, excuse me. I don't know how to get out of here. Okay, then there would be a 2 right here. So I have a 5/4 times a squared times b squared. All 3 of these are equivalent. Let's look at our next one. I have 48. I'll write it out normal. M squared n divided by negative 12 m n squared. Again, if it's helpful, you could separate your factorable factors. So 48 divided by negative 12 is a negative 4. M squared divided by m is m. Again, if we did this expanded way, it's a really nice visual. I have 2 m's on top, 1 on bottom. I can cancel 1 for 1, and that m is on top, right? So I'm going to write it right next to my whole number. Whereas this next case, I have n and n times n. So if I can cross cancel 1 for 1, I have an n in the denominator. So that's where that n has to live. Okay. If we solve this without looking at it in expanded form, so we just a little sidebar here. I'm just going to rewrite it. We could go piece by piece again, right? Kind of look at it like this. So I have 48 divided by negative 12 is a negative 4. Here I have m to the 2 minus 1, if I wanted to really show my work there. Then I have n to the 1 minus 2. Right? Remember, there's an invisible 1 right there. So if we simplify this, I have negative 4, m to the 1st, n to the negative 1. So I have negative 4, m to the 1st is the same as n. And a little review for those of you who have been with me this semester, n to the negative 1 is the same thing as 1 over n. So if we keep going here, this is great review or new information too. But now if I want to simplify this further, I can place negative 4m over 1 and just multiply across. When I multiply fractions, I can just multiply across. So a negative 4m times 1 is a negative 4m, and a 1 times n is n. And we see here we get the same answer, right? Originally, using the cross-canceling or canceling method, we have negative 4m over n. Here we get the same thing. I definitely think this first way is a lot less work, but this way on the right, the strategy on the right does show all your steps, which is kind of cool to see that it works. Again, I'm going to just rewrite this next one in fraction form. So right away, I'm just going to change my color here and separate my factorable terms. So I have a negative 76 divided by negative 19. That would give me a positive 4. Here I have a squared over a, which would give me a. B cubed over b would give me b squared. And c divided by c, we can just cancel those. So those completely cancel, so we don't have to put it in our final expression here. So I have 4ab squared. Let's separate them out here again. So when you guys are taking your GED tests, you don't have the luxury of all these colors, right? And the colors really help us separate our factorable factors and help us separate terms. It's a really nice visual. So you have to find something that works for you, because when you're taking your test, you just get a whiteboard with one black marker, right? So even when you rewrite it, if you were to rewrite this in fraction form like we've been, you could always just separate those factors out a little bit. Instead of writing them so close together, you can do the 24 and then a little space with m squared, and then a space with n to the 4th. Just a suggestion. 24 divided by 6 is 4. M squared over m squared, anything divided by itself is 1. So we don't need to put a times 1 here. We can just cancel those. And then n to the 4th over n to the 1st is the same thing as n cubed. So 4n cubed. I'd like to go over a couple of these. The difference between these division samples and the ones we've just covered are this is a polynomial divided by a monomial, where the last example, they were all monomials divided by monomials, which is likely what you will see on the GED test. But this is just one step further, and it's really not much different. Okay, so if I have that polynomial in the numerator of 9x to the 5th plus 9x to the 4th plus 45x cubed, I'm dividing each term by 9 squared. So it's kind of similar in the sense of when we multiplied binomials that was distributed through to every term. Kind of the same idea here. I'm dividing that entire polynomial in the numerator by 9x squared. So I'm just going to rewrite it under each term just to kind of separate that out. Big difference here is now, in this case, we have these plus signs. And those just don't disappear. We just have to keep those within our work. So if we look here on this the first term, 9x to the 5th divided by 9x squared, my 9's can cancel. 9 divided by 9 is 1. And now I have x to the 5th over x squared, which is the same thing as x to the 5 minus 2, which is the same thing as x cubed. Here's where I just can't forget my plus sign there. Same situation here with my 9's. 9 divided by 9 is 1. X to the 4th over x squared is the same thing as x squared. Next, I have 45 divided by 9 is 5. X cubed over x squared is just x. So it simplifies to x cubed plus x squared plus 5x. Same thing, I'm going to just share my bottom term between under every term in the numerator. So here I have 3 over 9. And 3 over 9 we can reduce to 1 over 3. So that's the same thing as a third. And then v cubed divided by v cubed cancels. That's the same thing. I'll bring my plus over. So here, remember, the coefficient is 1. So 1 divided by 9, I'm just going to keep that 1/9. And I have v squared divided by v to the third. So in expanded form, I have v. And here I have v times v times v. I can go 2 for 2. So I'm left with 1 more in the denominator. So that simplifies to 1 over 9v. Lastly, I have 2 over 9, which can't be reduced. I'm just going to keep it. And I'm going to do the extended way again here. This is v. The top's just v, so I can go 1 for 1. I have v times v on the bottom, which is the same thing as v squared. Sure. Next, 9n cubed divided by 9n squared. My nines can cancel. I'm left with an n. Next, I have a 1 over 9, so I have that 9th. And my n squares can cancel. They're the same. Anything divided by itself is 1. 3/9 can reduce down to a third. Excuse me. And I have an n on top, 2 n's on bottom, so I just have an extra 1 on the bottom. So n plus a 9th plus 1 over 3n. One little sidebar comment here, just to make sure we're all in the same understanding. 1 over 3n is not the same as 1/3 n. Okay, if that letter is in the denominator, that stays in the denominator. Okay, if it happens to be in the numerator, like this, that's the same as 1/3 n. Or if I have n over 3, that's the same as 1/3 n. If the n is if any variable is in the denominator, it stays in the denominator. You can't put it up to the side. Okay, so that's actually a really important point. I apologize it took me this long to say it. Okay, last one, we have 6kmn in the denominator here. And here I have 6kmn also. So 9 divided by 6 can reduce down to 3 over 2. K cubed over k, I have 2 more on top. M squared over m, I have 1 extra m on top, and my n's can cancel. So I apologize for my writing here, but that's 3k squared m, all divided by 2. Next, I have 3 over 6, so that's the same thing as a half. 3 goes into 3 once, 3 goes into 6 twice. I have an extra k on top. My m's cancel, and I have an extra n on top. So I'm just going to extend my bar here. So I have 1kn over 2. Next, I have 54 over 6, which is 9. K over k, which cancels. M cubed over m would give me m squared. And my n's cancel. So technically, this last term, this 9m squared, could be over 1. But you likely wouldn't see that because more simplified would just be a 9m squared. Okay, so I encourage you to go through the IXL lessons. That's how you're going to get good and comfortable with these, and practice them.